trying to analyze data using R. So this whole week, we have our great facilitators with us, Professor Balaba and Dr. Namaweje with us. Someone is saying my voice is breaking. Oh, it's their network, okay. So we want to welcome you, and we hope that you are going to have a wonderful time. We're going to have a wonderful time as you do the training. We want to welcome all of you, and we want to encourage all of you to attend the training today and all the days when we are going to have the training. We are going also to award you with certificates, but we encourage you, all of you, to attend the training for the whole period for you to be able to get a certificate. Previously, we have had people complaining that I have not gotten a certificate. Well, it's because you did not attend the whole training. So we would want to urge you to attend the whole training from today to the end. I would like to, already I know you know our facilitators, but I would like to call upon my colleague, Dr. Otto, to give some welcome remarks before we start. Dr. Otto, over to you.
Okay, and thank you, our trainers, Professor Susan Balaba and Dr. Helen Namaweche. These two people are very much experienced in this field, and I hope you, our trainees, will enjoy what they will provide to you this whole week. As my colleague has said, this is a follow-up training after we received requests from many of you that you needed more of this. But I urge you to pay attention to them and to use the various features that are provided in this platform for you to keep engaged. Being two, it means that when one is presenting, then the other will be available to support you. So it means, for instance, if Dr. Namaweche is making a presentation, you can always send in a text message to make a comment or say something in response to what is being delivered. If there's a question that you want to post, then the other will be able to support you. But these two people are very good in doing this training online. So please make use of them. I also take this time to thank you, our participants. We have received an overwhelming registration, and we hope that that interest you showed to register is the same interest you're going to show during this time. As mentioned, please help us just in a pseudonym. Please do write the names that will appear on the certificate. We have a lot of things that we do, so help us not to be spending a lot of time to, what is your right name? Just put in the right name during this whole session that you're going to be here, so that when we're providing the certificate, we just print out, we print out the names as they appear and then send. And I want to repeat, and without being rude, that please, we will guide you on how to change your name, but please write your name, including any title whatsoever that you want to appear. Let them be written on the names. And you can do that easily. When you click on your name, you can always go to more, and then there is rename. So rename yourself in case you registered wrongly, and then you put the right name, because we have extremely a lot of work. I mean, we are very busy, extremely busy. We do not have time to keep changing that. So I thought this message should come out strong, so you can we concentrate on learning. I mean, instead of these other administrative issues. That said, I want to wish you a very fruitful training, because this skill you need in order to sharpen your research. Some of you already have your PhD, others don't have, but trust me, for any research, you really need this skill. So these two people will help you, and we also provide additional time after the normal time for you to put in your question and to interact further with this trainer. So make use of these opportunities available to make yourself better. So otherwise, there's nothing much I would say, but to say we'll be meeting online, but I wish you all the best. Thank you very much. So I like all this guy.
Thank you, Dr. Otto, for those wonderful welcome remarks. I would like now to call upon our facilitators to start the training. Professor Balaba and Dr. Namaweje, over to you.
Okay. Thank you, Dr. Ronyararo. Thank you, Dr. Ronyararo, for opening the training today. And I would like also to thank Dr. Otto for also encouraging the participants to show the same, excuse me, to show the same response they showed while registering. The determination they used while registering for the course should be the same determination they should use while attending the course. They've already mentioned my names. I'll be facilitating this course, and I'll also give opportunity to Dr. Helen to greet you. Then afterwards, I will present the results that came from the training assessment. We gave out a short questionnaire to participants, and we had also a very good response. Thank you very much. Dr. Helen, over to you.
Thank you, Professor Susan. I'm so excited for yet another training that we are having from today until 9th of this month. I would like to thank so much Forum for giving us another opportunity to train students on how they can do data analysis. I thank you, the participants, for sparing time to join in the training. I know everyone is very busy and people are trying to make ends meet, but I'm telling you, made the right decision, because in any research that you need to do, most of the time, data analysis has to be somewhere, or it has to be part of the work that you do as you complete your research. I've already been introduced. My name is Helen Namaweje, and I'm a lecturer at Makerere University, and I'll be one of your facilitators with Professor Susan as we are moving on to this journey for the follow-up training. Welcome you once again.
Thank you, Helen. Thank you, Helen, for the introduction. Okay, we'll go straight to the results from the training needs assessment and also the overview of this course. Okay. I hope everybody can see the screen that I have just shared. And if you don't see the screen, you can put no in the chat. And if you see the screen, you can put yes in the chat. Before I start, we are going to use the Q&A for questions, and the chat will be used for comments. So Q&A is for question, then I can answer when Dr. Helen is facilitating, or the other way around. Then the chat will be used for comments. So I'm going to talk about the follow-up scientific data management course. I'll talk about the course objectives. I'll talk about the expected outcomes. I'll talk about your expected outcomes, and then also talk about a few results that you sent us. When we are designing this course, we expect that the participants will be able to perform basic inferential statistics, that is, use independent t-test, dependent t-test, under experimental and survey designs. The participants will also be able to compare means using one-way ANOVA, two-way ANOVA, repeated measurements. The participants will be able to manipulate field data in R, for example, using regression, simple linear regression, multiple regression, logistic, log linear, old norm, multinomial, etc. We also think that the participants will be able to learn how to use R Markdown, where they can store different commands, write R scripts, which they can, after converting into PDF, be able to open in Word document or PowerPoint, learn how the different efficient techniques used in data visualization in R programming, use R programming language to analyze data using categorical data analysis techniques and rank scores. And then at the end of the training, participants will be able to describe, these are our expected outcomes. We expect that the participants will be able to describe the fundamental concepts behind experimental and survey designs, including analysis with reference to developing countries, apply key statistical concepts such as regression, categorical data analysis, generalized linear models using R, use R programming language to describe, analyze, model the state of biological or agricultural system in both quantitative and qualitative manner, as well as fields like economics and health. For this particular training, we are only going to use R because R is a free software. We don't need to pay for license, and we are allowed to train online using R. Other softwares can only be used if we license them. So we can't actually show you how to use SPSS, GeneStat, Excel, etc. We are only going to use R because of the current conditions where we cannot move from one country to another due to COVID restrictions. Now, results from the follow-up training assessment. The main objective why we gave out this questionnaire of the follow-up was to identify the participants' expected outcomes and the stage of research process that would help us to know how to train the participants. Now, the expected outcomes, before I mention the expected outcomes, I would like to thank the participants. They gave us so many responses. We got 270 responses from the participants. Thank you so much. And we have summarized your expectations as some people have said they want practical application of knowledge with examples, daily assessment, and also we should record a file of the daily presentation and send it to you, which will be done with the help of the forum staff. To learn how to use R programming for my research, also gain skills in using R package. That is what we are going to use. But you remember this is a follow-up course, so we will just do a short recap, but most of the work is going to be new. Okay, we are following up from what is already done. If you want to know what has already been done, you go to the forum website, you'll be able to download all the videos that were used in August. So here are kind of research methods according to my research. So here this person wants to apply the statistical analysis to their research data, which you'll be able to do. So whatever we train or whatever is being taught, try to see whether it fits in your research. For example, if they talk about two sample t-test, find out, does it really suit my data? Do I have the data that was shown? Then you'll be able to practice when we are not training with your data so that you benefit from that training. Some wants to learn about statistical analysis, especially inferential statistics, be able to analyze my data qualitatively, how to analyze a full data set from experimental and survey using R programming. Yes, we are going to give examples of both survey and experimental data, and we are going to use R programming to be able to analyze them. Some people say we should give more practicals. Yes, we intend to give you exercises. For every day, we will have an exercise for you. And the next day, when we are doing a recap, we will be able to go through that exercise. Then others want to do data analysis and manipulation using R, especially ANOVA, Excel. We will only import data from Excel, but we are not going to use Excel because it's not licensed for training online. Some people want to look at the research process. When we had the first session of our training, we talked about the research process. We talked about methods of collecting data. We talked about surveys and experimental design. So if you want more details about that, refer to the videos of the August training. But we will hint on the research process. Part of the research process is data analysis, and writing and presentation of data. That's what we'll be doing. Some people want to know how to know the analytical procedures for DNA sequence data with R ANOVA, with R, especially with assumptions, when assumptions are violated. Also, ability to generate graphs from NGS data. We will not be able to handle DNA sequenced data or NGS data, but this is one of the recommendations we are going to make so that in case there is any training or in case we put up material online, then this can be part of the material that can be uploaded online for those to learn. But we'll talk about, if time allows, MANOVA will be talked about under multivariate analysis. Some people would like to know how to interpret results after running in R. Yes, that is a very important expectation, because if you just learn R and know how to analyze data, but without knowing how to interpret the results, then you don't know anything. So you actually need to learn how to interpret your results. Okay. Among the participants, majority were male, giving a proportion of 74%, and the least proportion were female, with a 26%. Most of the participants are at master's level and followed by PhD. Very few are undergraduate, and we find that there are some who are under others. I don't know what others means, maybe either of, maybe between the two, MSc and PhD. Let's assume so. Then We wanted to know the stage of research process, the stage at which the participants are, and we found out that most participants are at concept development stage, others are analyzing data, others are at proposal chapter, and I think analysis cuts across all these stages of research, because when you write a concept or develop a proposal, at that stage, you need to know how to analyze your data. So if you know how to analyze your data at proposal stage, you will complete your studies if you're a student in the record time of 2 years for master's and 3 years for PhD, because data analysis drives everything, and also interpretation and discussion. Okay, so suggestions for making the training a success. This is one of the questions. I wanted to find out, what do participants think? What do they want us to do to make the training a success? And the responses were summarized because they are qualitative, so you don't see percentages. But the participants say that we should record every presentation and share to every participant. This is going to be done. Even this part which I'm presenting will be recorded and forwarded to the participants. Participants have said they want to do more hands-on using live examples, which is really very good suggestion. We are going to provide examples of data which we are going to use in our analysis throughout the training for this week. Some participants may not have R. I think this is a follow-up course. My colleague, Dr. Helen, will hint on how to download R, but it is very simple. Even now, if you have a laptop in front of you and you log on to anywhere to Google and put in how to download R, you're going to get a PDF showing you how to download R. It is very easy. You don't even need to have any experience. So you can have your software now before the training starts, because when the training starts, we are going to do a recap. We are not going to install our software. So please, this is a request. Download the software now and install it on your laptop. It's not difficult, just follow the steps which are highlighted and you'll be able to have R. If you do not have R, you're not going to be able to follow. You will not benefit. So I request you, please, try to have R on your laptops, on your desktops, etc. I don't know whether R can be installed on a phone, but if it can't, then please get a desktop or a laptop so that you benefit. You never know. You might be one of the facilitators next time instead of me in R. Training material need to be given to participants before lecture days. Yes, that's what we are doing. And if you've not received the training material, you can put that comment in the chat. I will find it and send you the training material in the chat or in the Q&A. Training should be recorded. Send all participants in case we might want to watch it later. And for those who missed out any day of training, we are even going to, with the help of the forum staff, formulate a Google Drive where all the information will be posted and it will be accessible to everybody. More time to practice and reduce speed of training. Yes, we are going to go step by step. Other people call it process by process. I don't know, probably. Yes, but me and my colleague, Helen, we will try to go slowly and make sure people understand. Okay. Summary of the follow-up training assessment. Most participants are at MSc level and others are at PhD. And the stage of research process, which is common, most common is concept development and data analysis. The commonest expected outcome was that people want to learn how to do statistical analysis, especially inferential statistics, how to use R programming for both survey and experimental data, and also qualitative data analysis. Thank you very much. And those are the results from the responses you sent me. I now invite Dr. Helen to take over the training. Thank you.
Thank you, Professor Susan. I want to confirm in the chat if you can hear me. Can you hear me very well? Right. Kindly stop sharing.
Yes.
Okay, we've Professor Susan has just taken up the part of the responses that we got from the follow-up training needs assessment that you sent to us yesterday. Thank you so much for those that participated. Now I'm going to push on. As far as the program is concerned, we are supposed to have a recap on installation of R, extend the program, and then I'll move on to comparing two means using R with survey data, and then Professor Susan will look at experimental data, and then I'll also look at introduction to R Markdown. So basically, that's what I'm supposed to look at today, and then I will see what the day has for us. Okay. Like I mentioned earlier, we are going to do a recap on what transpired last time, but it's going to be very brief because I really believe that we all have the details of what happened last time. So it's just a recap, just to give us a push, a start on what exactly we are going to do in this training. Okay, you know, since the training is about using R programming language, you need R on your computer. Prof has commented already that using R, it's a free software. You don't need to buy it. All you need to do is go to internet, download it the right way. After downloading, then you have to make sure that you keep it updated because it's an open community whereby they keep building it up. So in case your packages are up to date, then it implies that you can even go in a remote place and do the work wherever that you want from, not necessarily having internet. So you need R on your computer and you need RStudio. I'm not going to go into the details, but how do you download R? We said that you go to the website, in case you're seeing my, my slide, www.r then pro-project.org, okay? And then there you can be able to download R. And I would like also to remind you that in case you're using R, you need RStudio, okay? Such that you are able to save your commands or the syntax that you're going to be writing as you're executing the different codes. And for you, in case you want to download RStudio, still we looked at it last time, you need to go to the website as shown and on www.rstudio.com/product/rstudio/download. And still in the materials that I sent, I still sent you a detailed format on how you can download both R and RStudio. I encourage those that have not yet done so, please go ahead because we are not going to go through the same process. In case there is a challenge, we'll always refer you to go to the videos that we had last time in the previous training. Okay, you need to install R. This was just option B, but the option A is I've already talked about. And in case for you to really be keen to understand that you've been able or successfully downloaded R and RStudio, in case you open it, this is the interface that you're supposed to see. Okay, you're going this upper part on the right, on the left-hand side, the upper part, which has got the RStudio. If you see on top, we looked at that last time. And then we have down here with the console where we execute our codes. The moment we run the codes in the RStudio, then they are seen, or the output is seen the left by the down bar. whether you've successfully imported your data. Okay, and then down here in the right hand, but the bottom box, which we has got the file, the plots, the packages. I remember we said that in case you run for a case of data visualization, all the figures within R are going to be seen in this particular workspace, the right hand side, the bottom box. And then in case we want to install packages, we're also going to do the same from this particular box. Okay, so that is the workspace, which has got both R and then RStudio. All right. Other important facts that we can remember in case you're doing R, remember, we have to install R packages. You know, like any exercise that we are going to do within R, we need certain packages. Okay. We need packages like we looked at last time, for example, read R, which is supporting us to import data, you know, from wherever you have it on your desktop, and various packages in case you want to do, for example, if you want to do linear regression, what package do you need? If you want to draw certain graphs, what packages do you need? All that particular information, we need it. And the moment we install these packages, it is quite interesting that you don't need to install them again. And then you just proceed on with your project. We also hinted on the fact that sometimes you can get stuck in the process. So you can tell R to support you by using the help command. You type help, then in bracket, you type in exactly what you want. R will support you to give you more info on how to use this particular command. We can also use R if you're using basic concepts in R, like arithmetic, adding, subtraction, division, multiplication, among others. R is case sensitive. The moment you record capital X, it has to be capital X when you want the output. If you record it as small x, then it implies that it will give you an error. It will bring a red mark to show you that, you know, there is a problem, or like the X is not being seen within the environment, or R doesn't know it. And so that's the reason you have to be case sensitive. If you're concentrating on capital, you're using your variables when they are capital letters, then let them stay capital. If they're small letters, then let them stay small letters. Okay, in case, as we are moving on, still a recap, when within R, if you want to assign a variable, you either use an equal sign or a less minus to assign a variable within R. Okay, so those two, we are going to be using those two things interchangeably. They are the equal sign or the less or minus, because when you're analyzing data, there's a lot of assignments that we do. So we need to understand that. And then we also mentioned that last time that, you know, when you're having data, looking at the different levels of measurements, it is always important to understand your data sets very well. In case you've got, for example, categorical variables, you need to alert R and tell you that, you know what, these are factors, such that as you're working out the different analysis, R is able to capture those variables as categoricals. And I remember we used as.factor function. Okay, still as we move on, we looked at what we call a data frame. And the simplest way how you can understand a data frame, it is like the data set that you're having, you know, the commonly term that is used, it's a spreadsheet. The way you see Excel, that data is how data is being entered. You've got columns, you've got rows, and then you've got columns and N by M matrices, okay? So still within our data, which is stored within the Excel, you can refer to it as a data frame, because all the data that you're going to have or you're going to need in the analysis, you're going to import it from there, okay? It is also important that within this data frame, all right, you understand what each variable means. You need to understand what each variable means. I've got a comment that, let me confirm again in the chat. Can you hear me? Am I loud enough? Okay. All right. Yes, we say that still when you look at your data set, it is always important to understand what each variable means, in the sense that you need okay, can you hear me now? Yes, we had issues with the network, but now it is okay. Sorry about that. Let me share again. Okay, let's proceed. Then when I get some, I'll send you the materials. So as we're proceeding, I was still saying that it is always important to understand your data set very well, because the moment you understand it very well, it will give you the right picture of the right statistical test that you're going to do. I was talking about in case maybe your dependent variable is ordinal in nature. There is some bit of order or ranking that is being involved. So you get to know that, okay, in case I'm considering a variable that it's ordinal in nature, then I need to understand at the back of my mind, then what statistical test am I supposed to use? That's why I keep insisting that you need to understand your data set very well. Some of the variables are scale in nature. For example, let's call them a continuous variables. Maybe that's the right term. Could be in form of an interval. For example, you can take age. Age could be you can look at it as a continuous, or you can go ahead and group them. Oh, so that they are in interval form. We further looked at how do we get the R scripts, because everything is being done in R. And I mentioned that, still I'm going to do it again as we go into the practicals, that within the R script, you go to File, New File, then R script. Yes, there is a concern about the training materials. I think people who have not yet gotten the training materials are not yet gotten the updated list, but we are going to send the training materials as we move on. I know, like with the list that I got, I sent the materials. Okay, so that was just not part of what I was talking about. So in case you want to write an R script, what we do, you do it in R, because it's where you're going to write all the codes and all the manipulation is going to be done from there. So you need to know, how do you get a new file or an R script within R? And then it's also important to use the comment, that is the slash, because sometimes it's hard for you to remember the things maybe you did some time back, and you need a quick recap on what exactly you're supposed to do. So what you can do as you're writing the different commands, all the different syntaxes, and besides, you can put a comment such that next time when you revisit, your R script, it is very easy for you to remember what exactly that you did. We further went ahead to look at importing and exporting data in R, okay, whereby we set the working directory. And also, please remember about the different kinds of how data is being saved. Depending on how your data is being saved in Excel, prompts you on how you're going to import it in R, okay? For example, in case it's saved as a CSV, then it implies that I can use the read.csv command in R, and then I import the what? I import my data. Of course, we use various options under the easy ones that we have. We also did data manipulation. And within data manipulation, there were many things, because I mean, by the end of the day, all data, whatever data that you'll collect, you have to manipulate it such that you get the right zeal of how your work is supposed to look like. For example, we looked at how you can create a new variable within your data. We are still going to do it again in this particular training because it's about manipulation. And by the end of the day, you need to achieve the objectives that you've set, okay? And then you can add a column or remove. You can subset your data. For example, maybe you did your data or you collected data in different seasons, and then you're like, no, I want to first analyze data for the first season, then I want to analyze data, then the data for the second season. So you can subset and then just have just a portion of the data that you want to analyze, and then you do compare it with the other. Okay, we also looked at data visualization in R, whereby we had some, like last time we had the bar graph, the box plot, the histogram, then the pie chart. And of course, like in any analysis, in any data analysis, all the things still come up. Data manipulation, we're going to do it again. Data visualization, I mean, we're still going to do it again in this particular training because sometimes it depends on maybe where you want to publish, or they can ask you that as you're presenting, in case you want to publish a certain paper, they can tell you we need a maximum of one plot or one graph, and then or maybe two tables, it depending. So we still need all this. And then we also, we did building a plot with a ggplot that was in the previous one. So now, that was just a recap of what we looked at last time. But in case you feel that something really is not yet so clear, like Professor Susan encouraged you, I would like to encourage you again that these are the links that where we had the previous training. They can support you such that you are able to have R on your computer, and then also the different stages. These are the links that we had last time, so they can support you such that you keep up page with the training. So they are all here for day 1, 2, and 3, and then 4, 5, and 6. So today is just a continuation, like we called it a follow-up. Okay, now I'm going to move on to proportions, comparing two means or proportions. But before I proceed, I want to share, because we need the material that I sent. I'm going to go in the chat and see if I can post the materials for those that have not yet gotten the materials, such that we move on the same page. I didn't send, really. Sorry. Please don't, because I'm trying to send the materials, but then when you keep posting, then it implies that since the number is big, the materials, you'll not be able to see them. So let me, so I've posted, just download what I'm posting. but you have them on your email as well. So I've sent the data set, then the R that we are going to use for those who never got. Then we have that. Download everything, and then I've got the lab 2. You send them. The what? Okay, I've sent the materials. Kindly download them, and then you let me know and we proceed. Kindly also post the YouTube link for the previous training. I've sent the PowerPoint. So within this PowerPoint, for those of you who have not gotten it, those links are there. So you can quickly get them, and then you paste them in Google, you'll be able to see those particular videos. Okay, so can I proceed? Or I give you 5 minutes to see that you put the materials together. I would encourage you that you get a folder, maybe a folder where you can keep your materials very well on your desktop, such that every time we talk about maybe materials for day 1, you are able to trace the materials very fast. Put in the Q&A. I can't see it here. Prof, have you tried to post in the Q&A? And somebody is asking that I can't see them also. Where is it? I haven't yet received. Okay. Nojja wano ku computer n'ekutwala n'ebijja kati mbadde nenzijja wano then nayo jjayo kimu kimu n'ogamba open nekigenda n'oddayo n'oddayo ekirala byonna mbibasendeka. I've sent everything. How many are they? I've sent the diamond data set. We are going to do we are going to use it. I've also sent the PowerPoints that I'm going through right now. And then I've also sent the lab-2 data set. Yes, there are 4 materials that you need. I've not got the 3 pieces of information. Hope it is that all. You need to have, yes, Professor Susan is also sending in the chat. So instead of, for now, don't post such that the materials do not get crowded within the chats and so on, such that you're able to download the materials. Where I can see them, check in the chat, and then at the moment you see what they have posted, all you need to do is click download. How can we get the materials? Kindly look into your chat. Stop posting and download the materials such that we get started. How can we get the materials? I sent the materials yesterday. Maybe there are some people who are not yet registered in the list that I have. So I'll get an updated list today, such that I make sure that everyone gets the materials. Okay. We are going to proceed now. I'm going to first talk about the theory part of it on proportions, and then later we are going to move into R and see how whatever that we've talked about looks like. And then we go through again how to import data in case you have it on your computer, then how we do some simple data manipulation. And then now we move on to proportion tests. And later we'll look at our Markdown because it's the outment of what we want to look at today. And I will also send you a simple exercise that you can try out. Okay, I'm asking the chat. Okay, somebody has already answered, James, that we proceed. Fine. Now we're going to look at, proportion tests. And or we're going to consider in case of a survey, and then in case of experimental design, which Professor Susan will look at. So under proportional tests, it could either be a one proportion test, or it could be two proportional tests, or you can have as many proportion, or you can have more than two. Okay, sometimes it's also called the sample proportion test or the Z test. Let me put my my face back. Okay, so the proportional test, they used to compare an observed proportion to an expected proportion. For example, most of the time when you look at our data, most of what you are seeing in your data, it's what we call observed. But you should not confuse yourself when you talk about proportion. What should come to your proportion? It's a form of like a probability or a percentage, like part of something, okay? And then, so what you're having within your data, for example, in case you're recording, maybe the prices of diamond, and the different diamonds that give you different prices. So those are the ones that are observed. That is the observed data. So in this particular case, we want to look at, we want to compare the observed proportion and then the expected, okay? Because most of the time when you're looking at what do you expect to get at the end of the day? Yes, you've observed this, but what is the expected outcome? So in that case, those are the expected proportion. And when it comes for a case of, this time around, you can have variables that have got, you can compare with only one variable, or you can have when you're comparing two variables or two labels. And most of the time, you're trying to test the equality of the proportions between these levels. For example, a quick example that I'll give, in case, for example, you're considering a diamond, okay? And you've got within the diamond data set, you've got prices where one is high and the other is low. So you want to see whether the proportion of the diamonds that of high price are equal to the diamonds that are priced with a low price, that are given a low price. So that is equality. So you're testing the equality within the given proportions. Don't I encourage you that don't get confused with what the word proportion is. Look at it in terms of probability, look at it in terms of a fraction, a proportion of something. Okay, now I'm still explaining about the proportional test, like the example I gave. You know, when you're carrying out the different analysis, most of the time there are tests that we want to do, okay? Now, for a case of a one proportion test or a one proportion, sometimes it's called the one proportion Z test. With that test statistics, in case you're seeing my slide very well, that we usually base on, we've got R, which this time around I'm calling my Z test, or the one proportion Z test, is equal to P naught. My P naught is the observed proportion. When we're talking about one proportion, it implies that, for example, you're looking at only one level, okay? In case if we are looking at price, okay, price of diamond, and you're only considering the diamonds that are priced highly, and you want to compare it with already the existing price, okay, whether those two match. And so for me to get my P, that is the observed proportion, my Q, that is the failure, which is Q1 minus P naught. So with the observed proportion, what we get, when we subtract it, we get the opposite. We know that success plus failure is equal to 1 probabilities. All proportion, you sum them, you get to 1 or 100%. And then PE is the expected proportion. So in case we are looking, for example, in case we are looking at, if I consider the price of diamond, and I'm only considering diamonds that are priced highly. In this particular case, depending in case what the analysis you're doing, that if you've cross-checked it with literature, it can be able to tell you that, you know, the expected proportion that literature shows A, B, C, and D of diamond. But in this particular case, for the data that we have, I've not based it on any literature. So what we are going to do, I'll just consider it as an expected proportion as 0.5, because in this particular case, the 0.5 is the highest proportion in a binomial experiment. That's why I've considered 0.5. And then our N will be the sample size. So let's go back to this particular example. Whatever I'm speaking, I'm going to do it in R, and we see how it comes about. I considered price with 2 levels, whereby the price for high is 37, and then the price for low is 67. Okay, 63, giving me a total of 100. All right. So now, if my interest is to check whether out of the 37 diamonds that are priced highly, with the proportion is 0.37, is equal to the expected, which in this particular case that I've termed as 0.5. Remember, I've picked 0.5 because I've not based it in any literature. So I'm taking 0.5 as the highest proportion that we can pick. Okay, and then my Q, remember that is the probability of failure. You get 1 minus the success. So 1 minus 0.37, I'll come up with 0.3. I'm doing all this such that I'm able to fit everything in this model in my equation here. But remember, within R, everything is done automatically. All you need to do, what command do I need to use? But it's also always important to understand what you're going to put into R such that you are able to really to come up with meaningful results. When you move on into R, I'm showing this particular table here, the syntax that we're going to have. You can either use a binomial test in case you want to test, to check if the proportions, the equality for proportions. You can use a binomial dot test. My X, that is the number of success. In this particular case, I'm looking at the number of diamonds that are being priced highly, only that, okay? For the binomial test, that will be my X. And then my N is the total, which is 100. And then my P, because I'm only referring to only the highly priced diamonds, which is 0.5. I've picked P, that is the proportion that I want to compare it to, okay? Or I can use the prop dot test, whereby I've got the same scenario. My X is the number of success, if that's what you're considering. My N, that is the sample size, and then the probability of success. With the prop dot test, you're free to change. You're testing it against an R, but it varies from 0 to 1. You have an alternative. You can test it either on two-sided, and then the correct will be equal to true. So we are going to do this in R and check what is the logic behind. Now, when you move on as just whatever that I've explained into the, I use the prop test, but in R we're also going to try the binomial test, and we're going to see to that the results are the same. Prof, I think I should go to R to make it more practical. Okay. Okay, I think at this particular point, let's move to R such that whatever I mention, you quickly see how it is in R, and I attach the explanation. Because, yes, let's go to R, and we do all this part there. We understand the concept very well. I'm going to stop sharing this. Kindly move to R now. Go to your computers, open your R, Okay, open your R software. Okay. I've opened my R. Remember, on top I've got RStudio, and then I've got the console window. All the codes that I run in the RStudio will be seen down here in the R console. And then for me to clearly see that I've successfully gotten my data in R, I'll be seeing everything in the environment. But right now it's empty. And then in case I've got maybe plots that I need, I'll see them in this, on the bottom box on the right-hand side. Let me ask in the chat. We are going to use the follup1.r script. Have you been able to open your R, open R on your computers? Okay, good. From the chat, what I'm seeing, people are saying yes. Now let's, okay, that is great. Now let's move on. Remember, like I said last time, okay. Okay, still I want to ask, do you have RStudio embedded in R? Does your screen look like the one that I've shared? Type 1 if yes, if your screen looks like mine, right? Somebody's saying no. I'm wondering, can you text in the chat why are you saying, what could, except one disproportion. Yes, I do have, somebody has commented. It said our console. Remember in the console, you're supposed to have a prompt, which is a greater than sign. Okay, so we'll come to that. I have only got one window, R console. Okay. I would encourage you, for those who've got R GUI for only for the Windows, kindly download R with the procedures that we sent to you. I have many other scripts from remind me how to clean the R console. Okay, somebody's asking the chat that I remind them how to clean the R console. All you need to do is type Ctrl-L, then you'll have a clean console. Yes, Emmanuel has posted it. It's Ctrl+L. You'll have a clean console like mine. And in case you've got R downloaded and you've got also RStudio, if you fail to see that, if you want to see that your screen looks like mine, just click on the RStudio, because when RStudio opens, you will see that even you will see that R is also embedded within RStudio. I'm giving you some 3 minutes and then I proceed. Click on R. Somebody's saying I'm going so fast, but I'm not explaining anything. I just want us to keep on the same pace. I want to first, before I show the one proportion test, I want to first ensure that everyone how to install 428 tab. Okay, Colin is saying that wait a bit. I sent a follow-up 1.r. It is an R script, okay, which I saved as follow-up 1. I mean, because it's what I wanted, such that it can easily, I can easily remember what I'm supposed to train on. Like I put 1 because it's for day 1, but there is nothing magic about it. You can change it to something else, or you can save it to your name. It is impressed that network interruption is becoming intolerable. Okay. How can I download? How can I download the software? Yeah. 4.4. Yeah, what is the latest? Last time we looked at how you can update R, but in case we were together in August, then it implies that your R is still up to date. So can I ask, can I proceed? How do I open follow-up 1 in R script? Okay, let me guide on that. In case you have your follow-up, the follow-up 1.r script, all you need to do, the moment you open up your RStudio, okay, just go, kindly see what I'm telling you. All you need to do, just go and click File, okay, from your RStudio, go and click File. Please watch what I'm doing. Click File, then come and then move down to Open File. The moment you click Open File, it will, then you need to move through within, you need to take a path to the folder where you've put the follow-up 1 script. For me, I stored it in the follow-up day 1 material. So that's why it is taking me there automatically. When you reach there, you click on it, and then after you click Open, and it will appear now in your RStudio. Is that okay? Is that fine? Okay. I think now we've been able, if you're opening the follow-up.r, follow-up 1.r script, go to File. I'm redoing it the last time. Go to File, move down to Open File, because you have a script already that you want to open. This time around, you're not composing a new one. Let me first show you how to open how to get a file from the folder that you already have on your computer. So you go to Open File. When you reach Open File, navigate on your computer to where that folder is, where you stored the different materials for this training. Then go and click on it and click Open. Automatically, it will appear in your RStudio. Okay, how did I get the follow-up 1.r? What I did was simple. Like we said, I came File, and then I asked R to give me a script. That is the new file. Then after that, I moved on to R script. The moment you click R script, it will bring you a new sheet. Which new sheet? Now in it, you can do all that you want. Install packages, import, export, and also go ahead and save it. Because in this case, if you want to save, for example, this new sheet, you save it any name by clicking on Save. For me, when I created that new sheet, I saved it as follow-up 1.r. Okay. Let me ask in the chat. Can I proceed? Okay, now very okay, perfect. Somebody saying it's my first training, I missed the previous one. Kindly find time and go through the the links that we sent last time. I have no R data, please. Prof. Susan kindly posted that again. Yeah. Okay, let's proceed. You remember, the moment you create an R script, you can save it. That's what I did. And there are some packages that you will need in all your analysis. Like we mentioned last time, for example, you need to install the tidyverse. I'm not going to install it again because I already have it. The moment a package is installed in your R, on your computer, you don't need to install it again. All you need to do is to now load it in library and run it, but you don't need to download it again. We looked at tidyverse, which supports data manipulation and making the codes more readable. We have the learn R that it makes it easy to turn any R Markdown document into an interaction. Since we are going to look at R Markdown, make sure you've got learn R as one of the packages, because if you do not have it, you will not be able to understand R Markdown. Okay, and then the read XL, which supports that when we're importing data. We had all these packages last time. In case you have them, please don't install them again. All we are going to do is to load them again in library. And then you can also have read R that support data exporting functions. Also the DPLYR, it is also embedded in the tidyverse and supports data manipulation and operations. The point is that you need like all these packages again, and in all, as you proceed, these are the basic packages that one must have to do an analysis. The other packages you keep adding, depending on the test that you want to do. Okay, now what I'm going to do, we are doing this together. Let's run our packages, okay? I can highlight everything. Okay. Can we add the packages for me who do not have them? In case you do not have the packages, you have to download, you have to install them using the install.package command. Okay, before I run mine, let me show you. If you're seeing my screen, if you do not have a package that I've mentioned about, you have to install it because it is the one that is going to support you when you're doing the analysis. Okay, if you want to install a package in R, all you need to do, type the install command. Okay, these commands are already embedded in R. Okay, install.packages, and then in bracket, you put inverted quotes, and then tell R the package that you want. Okay, for example, you can, because I don't want to install anything again because I already have it. Even when the package is installed on your computer, R will tell you that this package is already installed, so it will not reinstall it again. Okay, so, and then in the inverted quotes, you type in the package that you want, like tidyverse. The moment you come to the end, you click enter, and then you give it time in the R console to run. The moment after running, it will show you that you've successfully downloaded the package that you want on your computer. And then after that, all you need to do is now to tell R to load that particular package using the library command. Alice is saying that when I try to highlight all the packages to run them once, only one package. Yes, that is how it's supposed to be. You can as well run one package at a time, or you can highlight and stop. Then they will load themselves automatically until a prompt will come. So it is very fine. So I'm loading my package. Can I ask in the chat, can we proceed to, do you have the required libraries? Okay, now let's, okay. We need these libraries for what we are going, we need these packages for what we are going to do. Okay, now fine, let's move on. Let's install, let's load these package, the packages such that we proceed. So you just go, you can load every package one by one, or you can highlight them. It doesn't have any harm. No. I have a warning message when I was installing R Markdown, it failed. You do not need to install R Markdown. R Markdown is embedded in RStudio. So we are going to get there and I'll show you how to use the R Markdown. Okay, let's proceed. I'm loading. I've loaded my packages. The moment I highlight my packages and I run them, okay, I highlight in the RStudio, I go and click run, and then everything is executed in the R console down here. And the moment they appear blue, it implies that there is no error. You're free to move on, because even the prompt that you're seeing down here, it is telling you that, okay, what is next? Okay, let's proceed, that we have loaded the libraries that we are going to use. Now, the most important thing, the second important, after loading the libraries, we need to get our data into R, such that we do the proportions that we are talking about. How can we test for the proportions in our data that we want? Okay. We need to set a working directory. A working directory, remember there are various options on how you can import data into R. There is a direct method, which we looked at last time, but there's also another one whereby you can just state the path. You're stating the working directory. After stating it out, then it will be very easy for you as you come back again, because the path directory will already be there. So all you need to do will be very easy for you to call in R. Let me ask in the chat whether you've been able to set the working directorate. My R is now okay. Somebody's asking, is the meeting recorded? Yes, the meeting is being recorded. And yeah, someone is saying that I did it long ago. That's very interesting. Okay, so we looked at setting a working directorate. The point here is we want to import data in R. So move to a stage, we're importing lab2 data. So import lab2 data on your computer. I'm setting my working directorate. When you set the working directorate, it is unique to everyone because we are using different computers. So your working directorate might be different from mine or to the rest of the participants. So you have to set it, but it gives you the path where your data is. Okay, now I want to import lab2 data.csv. Last time we looked at how we can import data the various ways, but now I want to import lab2 data.csv using the read.csv command. And I want to call it an object. Remember, you can only have this, okay? Still your data will be read.csv, then that you're importing that data. But I also want to label my data, where if you remember clearly, I mentioned about an object. An object is the name that you are giving to your data set. So the object, usually, for you to be easily understood, it is always important that you equate it to, maybe you put an object or a name that somehow relates to the data that you're going to use. That's why I use my object as diamond. Okay, I said I've imported my data in R, which I called diamond. And now when you look in the environment, it is telling you that diamond has got 100 observations and 7 variables. Okay, so you're importing everything. Initially it was in Excel, saved as CSV, but now you're importing it into R, and R is telling you that whatever you've imported, it is showing 100 observations, of which it has 7 variables. And it's interesting, last time we said, you can still even view and see how your data looks like. If you want to view, you come to the environment and click on where I've put my cursor. All you need to do is click here. The moment you click, then you will see how your data looks like. Let me go in the chat and ask if we're on the same page. Kindly repeat the what? Would you please repeat again the command directory? Let me ask, have you been able to import your data? Before I do a quick recap, type 1 if you've imported. Some people are typing 2. I'm wondering what that is. Huh? We'll set the files in the chat. The console window has errors. One can see my data. The data is not available. I have the file, just importing them. Okay, from the comments in the chat, how to install packages. For those of us that are not on the same page or who did not visit the previous videos, I kindly encourage you to do so, such that we are able to move on the same pace. In R, in case you want to install packages, I mentioned you use install.packages, open bracket in the inverted commas, and type in. This is the command that you need. Okay, install.packages, then open bracket in the inverted commas, type in the package that you want to install. Unless you install a particular package, that's when you'll be able to load it in the library. Okay, in case you want to set a working directory, which is also another easy way on how you can import your data. Briefly, this is what you're supposed to do. Okay, we use the setwd command. Okay, you want to set a working directory. It is like a path. You're commanding R that my data is within a given folder. Okay, I'm going to stop sharing, then I show you how can, because sometimes the path is already embedded there. You already have it on your computer. I'm going to stop sharing, then I show you something. Okay, I'm opening my folder where I've got my materials. Kindly take a look. For those of you who are saying that you've not yet set the working directory, the easiest way, open the folder which has got your materials that you're using for today or for this training. The moment you open it, okay, you move up here in this bar where I'm putting my cursor and type and click in that space. The moment you click in that space, you're going to see what is highlighted. What is highlighted there, it is the path that you're going to use in R, because it is telling you that your work is on this computer, which is the C. You go to the users, then HNAM. Each time they put a slash, that is the navigation that is on my computer. Then you go into the follow-up materials and then follow-up the one folder. I encourage you, copy this line, this line here. Copy whatever it's highlighted. All you do, just right click, then copy. The moment you copy it, that is the path, that is the path you're going to use as your set working directorate in R. Okay, so I'm going to stop sharing this and now I go back to R. But remember, I've copied my path from here. Okay, now I'm going to go to R, my RStudio, then I share again. What you can do, okay, just paste the path that you copied there into anywhere in your R script. The moment you paste it, that is the path that R is telling you. However, when you're using Windows will read it when you've changed the backward slashes into forward. So all you need to do is to turn what was backslash into forward slash within your path. Okay, you do that. You go and do that, everything. Remember, this path is unique. Okay, now having changed everything into forward slash, all you need to do is to put a command, setwd. Setwd, you open bracket, and then in inverted commas, you put your path, and then you close. So whatever that I've done here, it is you've set the working directorate. You're telling R that all the materials, that all my R script, all the data that I'm going to import, it is you follow this path up to the follow-up day one folder, or up to whatever folder that you've put your material. And then you have to run it such that the moment you run it, if you see that in your R console, you've not seen any red mark, it implies that the path that you've selected is right. I'm going back in the chat to ask, is the set working directorate okay? I'm seeing people sending their email accounts. I don't know why you're sending them. Perhaps somebody saying that they didn't get the material, they can resend. Okay. All right. Okay. Someone has commented that I've been able to import my data and even to view. Okay, I'm asking in the chat, can I proceed? Have you been able to set the working directory, imported your data successfully, and been able to view it? Okay, great. Now let's continue. I'm seeing many people are saying that, yeah, they're okay. They have set the working directory. We're importing the lab2 data.csv using the read.csv command. Okay. In case you want to view how your data looks like, for those of you who haven't, I said, when you look in your environment, it is showing you that the diamond dataset. Move at the extreme end, whether there is an icon like an Excel sheet with the small boxes. It has a blue top. You click on it. The moment you click on it, your data will open in your RStudio, and you'll be able to see the 7 variables they talked about, that you have a variable weight, quality, color, price, length, width, then depth, etc. You might have more. I'm going to close that because I do not need it. Now let's proceed. Remember, the point of telling R about the nature of your variables. You can type str, structure. We looked at structure last time. Structure diamond, and then you run. It will tell you that when you look in your R console, it will show you that weight is numerical. It will tell you that for it is seeing quality as a character, color as a character, price as an integer, length, width, depth as a numerical value. But remember, quality and color are categorical in nature. So you need to tell R that, you know what, let quality and color be categorical. We use the as factor, as.factor command. If you remember clearly what we said, that now we know we've labeled our data set as diamond. So if you want to pick a variable from this diamond data set, we use a $sign. For example, I can say diamond $, okay? And it even tells, it comes like, you get a drop down. It tells you that within this data set, these are the variables that I have. Which one do you want? That's why I'm telling the $sign, it helps you to pick this particular variable. That pick for me quality, okay? That then you assign that less or equal. I want to tell R that this variable is a categorical in nature. That's why I type as.factor, then in bracket, I command R, but diamond, then slash quality, the same thing. Or I can copy this part here and then I paste it. So in that case, you're telling R that no, look at quality and color as categorical in nature. Then you click at the end, you run, and you also run the color. Let me ask in the chat, have you been able to assign quality and color as categorical variables? I'm giving you 2 minutes such that you please do. R is interesting in case you master the principles, because these are the principles that we need and things will be easy. Okay, let's proceed. All right. Okay, now, remember, I'm going to look at my ultimate aim. I want to look at proportions. I want to test if whatever proportions that I want to test are equal. All right, but still, I need to do some data manipulation. Everything emanates from the objectives of your study. What are the objectives of your study will give you a way forward on how your data can be manipulated. So I went ahead to ask, because my aim was looking at the factors that are affecting the price of diamond. If you remember if you remember what we discussed, that all these factors, the variables that we are having in the data set diamond, all of them affect the price of diamond. So, but we can do some simple manipulation such that we are guided clearly on what we want to do at the end. Last time we said that you can get a continuous variable and manipulate it to a categorical variable. So what I want to do is, instead of having my price of a diamond as continuous, I can manipulate it into a categorical. Okay, I can manipulate it into 2 levels. But depending on the criteria that I want to use, I'm going, sorry? Okay, somebody's asking that, what does the $sign mean? The $sign, we use it when we want to call a variable in a big data set. Okay, for example, in our diamond data set, we've got various variables. For example, like quality, color, etc. So in case I want to command R that in my data set, call for me quality variable, then what I'll do, I'll use the $sign. Okay, like what you've done up here. I say that I want the diamond from my diamond data set, call for me the quality variable. And I want it to be a factor, so I use as.factor. The same applies to color. Okay, now let's proceed. We are moving on to data manipulation. We are doing the manipulation such that we are able now to do what we want, but basically, I zoom, control. It's Control-Shift+. Okay. I think now it's more clear. Am I fast? What does as factor mean? Okay, we need, you are not fast. I'm following with you very well. Okay, not too fast. Okay, let me try to moderate the speed because such that we are able to, we want to, remember our follow-up training is advanced now data analysis. So I want us to move to that page, to that pace now, such that at least we achieve something before the day closes. Okay, speed okay, but more clarity always on the signs. Fine. If you have a question, if there's something that you feel is not clear, just type it in the Q&A. Professor Susan is on the computer and will be happy to answer all the questions. And then I'll also be reading them here such that I can throw more light for those that I can see very fast. Okay, now let's move on. We are moving on to data manipulation, okay? We are moving on to data manipulation because we are going to test, like I said, price is, it's when we checked in the structure and they told us that the price was numerical in nature. But like I said last time, that you can manipulate this data to what you want, but all emanates from your objectives. What is the objective of your study? So I want to consider price. When I run price, I know it's continuous. I can run a summary of it. When I run price in when I run price in my console, they are telling me that the summary, descriptive statistics. I stopped from setting a working directory. So Prof, how can we help this one? Gerard is saying that he stopped on setting the working directory. Gerard, please follow as we are working through, but you need to get the steps on what we are doing. Type, can I continue or I give you some 5 minutes, some 2 minutes for those who are saying that I stopped on the working directory? All the commands that I'm using, they are in the follow up 1.r. Okay, let's continue. Prof has sent the follow up 1.r. Somebody recommend that we have a break room to consult so that others can proceed. For those of you who might be stuck as we're proceeding, we're going to have a support session for 30 minutes after the general training, so we can support you individually in those sessions such that you don't feel left out and discouraged. Let's proceed. Let's continue from here and try to follow what we're doing. Then join in the support sessions. We will support you. Okay, so what I did, I said that from my price diamond, okay, I've got the minimum, I've seen the minimum price and then a maximum price. But what I was interested in here was the mean. My mean was 4534. And I said that now I want to categorize, I want to create a new variable, which I want to call price cut using the if else command, okay? If else, it is a logical, it's a logical setup, okay? For example, I want to say that if price is equal to this value, if price is greater than my mean, call it high. Otherwise, let it be low. Okay. Now I'm here. I want to create another variable, which I'm calling price cut. Why I'm putting a diamond, I'm telling R that on top of the, within the R data set, okay, create for me another variable on top of the variables that you have. Create for me another variable, price cut, because I don't want I don't want to lose the price variable that I have. So I just want to create another variable called price cut, okay, using the if else command, but it's being generated from price. And I'm telling R, kindly look at what I've highlighted, okay? That is the if else command. So within the if else command, where the moment you open the brackets, I've put test. Test implies that what do you want to run? What test what quest can I put in across? That is the test I want to run. So in this case, I'm saying that within the My Diamond data set, where the price is greater than 4534, when you come here on this second line in the if else, this is my test, that the test that I want that go into My Diamond data set, okay, pick price. The moment it is greater than my mean, which is 4534, okay, call it high. This is the command, C bracket, call it high, concatenate it with high. Remember we said C is concatenate, putting together all those figures, all the numerical numbers that are greater than my mean. I'm going to call them high. If I don't call them high, then what else? Otherwise, call them low. So all the prices that are less than the mean, call them low. It is what I'm fitting in this part that I've highlighted. The if else command, you first put in the test. That test, what do you want to call it? That whenever where my price is greater than 4534, call it high. That is the second part, comma, the second part, what you want to call the test when it's observed. Then otherwise, let it be low. Okay. Now, when I run this line, the moment I run it, you look in your environment and see that now your variables have increased. Initially, they were 7, and now they are 8, because I told R that create for me another variable called price cut. I'm manipulating this part such that it supports us as we're doing the proportion tests. That's why I'm insisting that we need to do it, because whatever that you want, you'll always have to do data manipulation. Okay, and now I can also view and see what happens in my data. You click on view. When you click on view, you see that now you see a new variable which has price cut. Okay, and when you go and check, if you want to confirm that what you've done is correct, remember when you look at the first observation, your price is 6414. It implies that it falls above the 4534 mean. So R called it high. Okay, when you look at 1323, the second observation, it is less than my mean. So R called it low. In other words, I got the price cut variable, I manipulated it from the price variable. I'm going to go in the chat and ask, are we on the same page? Does the new categories for price cut automatically have codes 1 and 2? Okay. No, it is not automatic, but you can rename and tell R that where there is high, put 1. Where there is low, put 0. You see? It's all about what you want to do. If you don't want to see the high and low, you can rename and tell R that, no, go to the price cut. Where there is high, call it 1. Where there is low, call it 0. Everything is about what you want. And as you're doing your analysis, you're going to do a lot of manipulation. Okay, let's continue. I'm seeing in the chat people are saying that it's fine. If it is not fine, please hold on and then try to see what we are doing next, and we'll support you during the support sessions. I also have another variable called, now we are learning how to use the if-else logic, because it is also important that most of the time when you're doing data analysis, you need it. You're going to be using it every now and then. Sometimes you might have a lot of data and you want to condense everything. So you can use the if-else command, the logic command. Okay, now I'm moving on to, let's try also one thing more on how to use the if-else command, such that when we proceed, it becomes very easy. Okay, now I'm putting table diamond. I want to get the frequency for color. Remember, these were categorical variables. So I run. The moment I run, when I look in my console, those colors where we have D, E, F, G, H, I, J. You know, from what I'm doing, I saw that this one, there are a lot of colors. Why can't I condense them into 3 colors? Instead of having from D to J, and I condense them into 3 colors. That is black, blue, and gold. So I still use the if-else command. I put my test, okay? And then I put what I want to name it, and then what about otherwise? I'm going to go through this command very slowly, such that if you're able to follow, that will be very nice. So colors, I create another variable. Remember, I want to maintain everything I have in my data set. So what I do, I create another variable, which I'm calling colors. Okay, I'm calling colors like the way I created the price cut. I'm calling another variable colors, such that it also becomes a new variable in my data set, because I'm going to use it depending on the objective that I have. So I use the I use the if-else command. So I say within this column, the colors, which I'm going to manipulate from color, okay, that if else, what is my test? Diamond color, when it is equal to D, okay, I'm saying this D here, call it gold, okay? Because this time around I've got many groups, I'm not going to put the otherwise right now. I moved on, I said comma, if else, again, the diamond color, if it is E, call it blue. Okay, I've not put the right. Then I continue that if else, comma, because everything is going to be, it's in one line, only that I'm breaking them. That if diamond color is equal to F, this F here, call it black. Because what I'm doing, I want to condense all these colors, the G, D, F up to J, into 3 colors, gold, blue, and black. I told R that where it is green, call it black, label it black. Where it is H, label it blue. Where there is I, label it gold. Then what about the otherwise to complete? Otherwise, the remaining bits, call them, give them the blue color. Whatever that has remained, call it blue to complete the logic question, the if else. Okay, so now when you run this at the end in R, the moment you run that if else, then the moment if you don't get any blue, sorry, if you don't get the reds, it implies that the command you've put is right. Okay, now I've created, you can still check in your view, you're seeing colors. Now, this colors has been manipulated from color variable, because you commanded it that where there is G, call it black. Where there is D, call it gold. Where there is H, call it blue. So it is being done automatically. All you need to do is to know is how do I make a setup. Okay, now these are the two variables that I'm going to concentrate on as I proceed. Remember, now they're all categorical in nature. I can still go ahead and tell R, look at them as categories by running the price cut as a factor, and also colors as a factor. Okay, I'm going to pause in the chat and ask, are we on the same page? Goodwin is asking that, please several brackets at the end. You're replying. Okay. Great. Prof is answering that. Great. I'm seeing people saying that we're on the same page. Now let's proceed. Now I'm only going to work with only those two variables, the price cut and then the color only as we proceed on. So like in any data set, feel free to find the frequencies. Now I'm running again the frequency for colors, which we looked at last time. Descriptive statistics is part of analysis. I'm seeing that now my colors are 3 in categories. Black, they are 36. Blue, they are 38. And gold, they are 26. Okay? You can also create an object and put your colors in an object. I created an object call, okay? But you can label it anything, it doesn't matter. That is what I was interested in. And I put everything here in an object. There's nothing that I changed. I said, let me create an object to be equivalent to that. So that's what I did. Call, I assigned it to table diamond color. I ran that. Now to see what is within the output, I run the object call, and it will still give me similar answers. That, okay, your black, the blue, and the gold is equal to this. You can get proportions, or call them, you can get proportions of each. For example, in this particular case, you can get the proportions for each color. And how do we do that? We use the prop.table command. And in this particular case, all I need to do, I just fit in my object, because my object is the one that has got that has the frequencies for the colors. So using the prop.table command, I run that, and it's telling me that the proportion for black is 0.36, the proportion for blue is 0.38, and gold is 0.26. Okay, if you want to put them into percentages, all you need to do is to get this same command and type it by 100. Okay, you type by 100, and then it will give you the answer. You run that. Sometimes when you're working and you've got many decimal points and you want to reduce them maybe to 2, that is if applicable, all you need to do is type the round command. If you can see on my table, on my screen, even round in bracket X, what do you want to be rounded off? So you tell R that round off everything here. From the result that I have here, round it off to 2 decimal places. But in our case, we are not rounding it out of anything, because everything is already there. But so that's why I put a comment that you round off if necessary. Sometimes when you've got many decimal points, you can use the round off command. Okay, let me go into the chat and ask, are we on the same page? How to categorize price in 2, 3, for example. How do you do it? Okay, let's proceed. If you can manipulate your data in anything that you want. If you've got price, so far we've just looked at only two, which is the high and the low. But you can say that no, I want to have three categories. You can have high, medium, then low. It depends on what you want and referring to your data. So now let's move on to now the proportion, the one proportion test. Like I said, what I've done here for the case of color, you can do it for price. You get the proportions for price, which are the ones that are for high and low. What would be the level for price exactly equal to? I just used the mean. There's a question, what would be the label for price exactly equal to the mean? I just used the mean to support me to create the categories that I want, okay? In the sense that because I wanted to create a two category, and I said, well, looking that it's numerical in nature, I can consider this because we know that mean it measures the central tendency where most of my data is concentrated. And it is a good statistical measure somebody can use to make an argument. So it's a reason why I used my mean as to support me in creating my categories within the price, which is high and low. And in case you want to create three categories, maybe high, medium, and low, automatically it will change, it will not apply. It's a reason I'll keep on telling you, depending on the objective that you want to achieve. Okay, let's move on to now one proportion test and see what we can do. Like for the case of the slides, I say that it's used to compare an observed proportion to the expected proportion when the variables has only two categories, okay? We are going to first consider when we have only one category, and then also when we have two categories, and then when we have more. All right, now within R, there are different tests that you can use. If you're seeing we have highlighted, you can use the binomial dot test, which is the first one. I've already explained what R is, what our X, that is the success, the number. I make it wide. Sorry? The words are small. Okay. I hope now you can see my words very well. Kindly, as we're walking through, also you need to check on what we are doing. So I can use the binomial test. Remember, we are looking at proportions, okay? And so my X, the vector, the X, the first one, that one tells us the number of success. And the first one, we are going to consider the success as the price of that's the diamond. The diamond price is high, is what I'm going to consider. Then my N, that is the sample size. And then with the binomial test, our P by default, we are going to use 0.5, okay? Which is the one that I said that has got the highest proportion in a binomial test. In case then you can test for the alternatives. These are, if you're testing for the hypothesis, you can use a two-sided test or a hypothesis, sorry, or you can use a less than or greater than. But by default, it shows you that the two-sided. Or you can use the prop dot test, this one here, and still the same explanation, my X, the number of success, then N, that is the sample size. When we use P in this particular case, the prop dot test, our P, we are testing it against the alternative. For example, in case you want to compare two categories, are the prices of in case you're looking at the diamonds, we've got two prices. Are they equal to, or the probability that these two prices are going to be equal? So that is why we have our P equal to null. I've already explained that we test whether the proportions are the same among both sizes. We are testing proportion if the one of the diamonds that are priced highly is equal to the one when the price is high, or it is, or the alternative, the alternative, it is not true. We'll use the prop test, but now let's proceed. I've already talked about the arguments that we need, number of success, number of observations, and then the expected probability. Now, let's start with the price. Okay, I'm considering the price cut, which has two categories. So in this case, I created a variable called cost, okay, and I assigned it to a table. This one is going to give me the frequency. The numbers gives me the frequency. So I get to find out. When I run that, I also run the object. When you check in the console, it is showing me that the number of diamonds that are highly priced, they are 37. And the number of diamonds that are lowerly priced, they are 63 proportions. So in the prop table, I can come here and say prop and table to see the proportions. So I put prop table to give me the proportions of for the cost. When I run that, it will tell me that the proportion for high is 0.37 and the one of low is 0.63. So now what we are going to do, we are going to put a claim that since I've got that out of I've got 37. When you look at the figures that I have, the high are 37 and then the low are what? Are 66. So we want to test. I'm only going to first consider only the high, and then testing the two proportions will be considered later by using the binomial testing against the proportion of P equal to 0.5, whereby which I said is the highest proportion within the binomial. No good. Okay, so now this is the test that I'm going to run. Okay, I have a claim that 37 out of 100 diamonds are highly priced. So, but I want to find out. I want to test it against the P, which is 0.5. Like I said earlier, that our P in this particular case, you can use it in case you've got literature that, for example, they can say that in literature, most of the highly priced diamonds, they could be, the proportion is, it could be, for example, 0.8. But since the data that I have is not based on literature, let me use the general one of 0.5. So I want to test and check whether whether the 37 diamonds, remember my X now is 37. These are the diamonds that are highly priced. My N is 100. All I'm doing is I'm fitting into my test, and then my P is equal to 0.5. I'm using the binomial test, but in case I move on to the prop.test, I can change this particular P to any, testing it against the null. Okay, so when I run this particular test, I've put it under the object called one test. Okay, I've also put some explanations within the R script, which you can follow. So in case I run this, okay, in case I run that, I also want to see the output. What does, my object is one test. I want to find out what is in the one test. So when I run that, when you look in my R console, this is the output that I have, okay? It has given me, within my data, I've got the number of success at 37. Those are the number of diamonds that are priced highly against the trials of 100. And I'm given that the p-value is 0.01202. Remember, the now that I said that my p-value, I said that the p was equal to 0.5. And the alternative that is giving me here is telling me that the true probability of success is not equal to 0.5. It also gives me the confidence interval and the probability of success as 0.3. So now, the conclusion we can have here, look kindly, I want to highlight this particular bit, that the probability of success is not equal to 0.5. But we are given that our p-value is equal to 0.01203. That's what we are having. So given that the alternative they're telling us that it's not equal to 0.5. Remember, our alternative is either less or it's either less or equal to 0.05. But in this particular case, so we will conclude that the probability of success, which it's not equal to 0.5, as we are having the probability of success to be 0.37. It's not there. Okay. Let's proceed. I'll send somebody saying that what is missing, that the code that I'm running, you don't have it with you, but I'll send an updated part. So that was for the case of the binomial. But remember what we are, from the output, what we are having, the null, we are testing is against the proportion of 0.5, okay? We've got the chi-square test, that the test statistics, which is 6.25. We've got the degrees of freedom. We've also been given the p-values and also the confidence intervals and the proportion in the sample, which is 0.37. Now, the conclusion that we are saying that the null hypothesis we set, which was 0.5, we are rejecting it against the alternative that the true value or the true proportion is not equal to 0.5. In this particular case, it is either the alternative, either greater or less than, because we are talking a two-sided, which was 0.3 as the proportion of in the sample. So which is less or equal to 0.5. The other assumptions that you can think about when you're running a proportional test or a binomial test, that most of the time, you can use a binomial test with assumption that if your size is large enough, that n is greater than 0. And when your n is greater than 0, you can use the prop test, or when you think it is smaller than it is small, that is n less than 30, you can use the binomial, the exact binomial, you can use the binomial test. Now let's run the same thing using the prop test, okay? I'm not changing anything, I'm using the prop test. But this time around, what I'm going to do, for the case of this one that we've just gone through, this command that I've just highlighted, we tested it against a 0.5. Okay, but still you can, we use the prop test. Here we use the binomial test and we came up with the results. You can still do the same thing using the prop test, because both the binomial test and the prop test support in testing the quality in the proportions. So in this particular case, I can do the same thing, but now this time around, instead of using the bind.test, I use the prop test. All the other information remains the same. I'm also still testing it against the 0.5, okay? That I'm testing for the equality of proportion that my probability is 0.5. For the case of only when the prices, when the diamonds are highly priced, this is only one proportion. Then we're going to move on to 2 proportion. This is 1 proportion. So when I move on, also what I do, I come and click. I run that point, that line. When I run that line, I come and I want to see the output. Seeing my output, it is still the same thing. The output is the same. It is telling me that 37 out of 100, our 37, these are the highly priced diamonds out of the 100, which is 100. And I'm testing it against the null probability that I said, the proportion, which is 0.5. Still, my p-value is significant. Sorry, my p-value is less than 0.05 with my x squared, my chi-squared, which is 6.25. I'm given the confidence interval as 0. that to that, and the probability of success, which is 0.37. So still the conclusion is the same, because the alternative we're having that the true P, our true P, which is 0.37, is not equal to 0.5. So we are rejecting the null of the 0.5 to take the alternative, which supports that it is either less or greater than 0.5. Sorry? Okay. Okay, let me send the script. Okay, I need to. Sorry? Hmm? Okay, I'm told that we have only a few minutes remaining. Let's proceed, and then we'll clarify more things during the support link. Also, I said the bio test or the prop test, you get similar result in case you're considering only one group. Now let's look at a scenario in case you're comparing both groups. Maybe it will make more sense. Now this time around, instead of testing it against the alternative, I'm looking at it, the X, the number of success, which is 37. Okay. Remember our proportion in that case, it is 0.39. My N, which is the total number of trials, they are 100. And then the P, now my P, I'm setting it against the P, this time around is 0.63. This is the proportion when the diamonds are being priced with a low price. So we want to check whether the prices for the diamonds that are highly priced are equal to the diamonds that are lowerly priced. Are these prices equal? And if they are equal, are they significant or they are not significant? So what I'm changing, the number of success is still, I'm considering 37, okay? Then the total number of trials, those are the diamonds that I have. But this time around, I'm considering two groups. The group for diamonds that are highly priced, and then the diamonds that are lowerly priced. So now this time around, my P, which is which I'm testing it against, is equal to 0.63. That is the proportion for the case of diamonds that are lowerly priced. So what I do, I run that. The moment I run, I also want to see what is happening in my output. Okay, now let's look at the interpretation of the results. We want to check whether the prices of these diamonds are equal. The diamond, remember in the prices, we have those that belong to the high category and those that belong to the low category. So in the data that we have, we are considering 37 out of 100. The 37 are the highly priced diamond. We are testing with the narrow high probability of 0.63. This one is for the case of diamonds that were lowerly priced. That is our alternative. We are given our p-value as 1.28 is 0 that. And the alternative hypothesis that we are given, they're telling that the true p is not equal to 0.63. So it implies that in this particular case, since the true value, the 0.3, which we are testing against the 0.63, these are the proportions that we are testing. Since they are not equal, it implies that they are significant. The conclusion we can give is that the prices are significantly different for both the ones that belong to the high price and then the ones that are the diamonds that are lowerly priced. So the prices of these two are significantly different because our p-value is less than 0.05. And also from the concept that when you check the alternative, it is telling us that the true p is not equal to 0.63. So we'll pick up with the alternative. Let me go in the chat and ask. We need a break if possible. If they need a break. We are about to break. Unfortunately, I've not covered the part of our Markdown. I thought I will do it, but we've not. But they need a break. Huh? They need a break. The p-value is 1.28e-09. So it's the same as 1.28 times 10 to power negative 0.7. Let us finish at once. They need a break. What does the... Okay, let's proceed. Kindly note this one. Somebody was asking that it's 1.28. It is 1.28 times 10 to the power negative 7. So it is less than 0.05. Please note that. Okay, let's continue. We are going to share the recording, so please keep on. Let's proceed in the remaining time. That was we looked at a one proportional test. In case you're only looking at one level, we've looked at the two proportional tests. If you're comparing two levels where you want to see if they're significantly different, in this particular case, we check that the proportions, it is true, we pick the alternative that they are not equal. The proportion for the highly priced diamond is different from the proportion for the lowly priced diamond. And they are significantly different because our p-value was less than 0.05. Okay. Within the data set, I'm going to leave an exercise for you as we proceed, because we want to move on to our Markdown. There is also this particular command in case you're testing more proportions. We still even have it in the PowerPoints, whereby you want to check whether the prices of colors are significantly different. Remember, our colors, we've got blue, black, and gold. So this is the command that you'll have to run. We are taking it as our homework such that you can also attach meaningful explanation. Then tomorrow we will share about the results that you have and check if the explanation that you've got is the right one. So in the remaining time, I want to proceed on to our Markdown such that we don't close without having looked at that. The rest of the parts that you can go through yourselves. Let me check in the chat. Can we proceed to our Markdown? It is going to be easy, then we can stop. All right. Yes, we are going to share the materials on email. Just be patient. Okay, let's look at the R Markdown, because last time people were saying that we want to see how the R Markdown works out. No codes for R Markdown. No, we don't need any code for R Markdown. It is very easy. We do not need any code. Now, listen, let me slightly go back to my slides and show you what is happening in the R Markdown, and then we come back to R. We see the relevancy of R Markdown. Maybe majority of you have encountered it all along. Can you give the all procedures of the exercise? Yes, we'll text them. Let's first proceed. I'm going to first stop sharing. Sorry. Kindly note that the support Zoom link will start at 2. Okay, this one is what I've just explained. Now let's move on to R Markdown. You know, sometimes when you're writing these many codes, it reaches a time whereby you still get tired of rerunning these things again. So what R Markdown does, it is like a notebook where you can put all your work, and you can even it is also like a saving style whereby you can convert your work into HTML, into a PDF, or you can convert your work into Word. That is what an R Markdown does. So it is like a notebook whereby you can refer to it anytime that you want. You don't need to run your R codes again. You run them at once, you put them into R Markdown, such that as you start writing your results, maybe into a publication, you just go get the results you have in the R Markdown in whatever saving style that you've used, and then you start writing them down without rerunning R codes again. So what it does, it executes all the codes. It executes for you your command, and it goes ahead to give you the results as well. That's why I'm saying it like it's a notebook. So from it, you can hint and get HTML files, PDF files, or Word files. For more details, you can visit in the link I've put the link. So how are we going to do it? There are various options and very simple. We are going to go into R, and you click File, New File. Now, instead of when you go to the new file, instead of picking R script, we are going to pick R Markdown, okay? And then you see a certain screen is going to display, for example, which has got new R Markdown. So when the moment that it displays, you're going to save it any name that you want. After saving, you can go ahead and edit in 2 different chunks that you want, such that you are able to have your codes run well. Now, this is how it's going to look like. We're going to go back into R. With option 1, like I said, you go to File, New File, then R Markdown. The moment you go to R Markdown, this is what you expect to see, okay? Within this document, it will tell you, how do you want your results to look like? Do you want them to appear as a presentation? Do you want them to appear as a document? For now, I want my results to look like a document, all right? You can save any name that you want for your Markdown. And now they are telling you that the output that you might need to use are 3. You can save it as an HTML, you can save it as a PDF, or you can save it as a what? As Word. All these are different saving styles within R Markdown, where you can go back anytime without running R again and get what you worked on earlier. Okay, option 2, the other one was the first option. Option 2, if you're saying where I'm moving my cursor, all you need to do is you just come and click on this drop down here. And then the drop down has our script, our notebook, but you go to our Markdown, then you click here. So now let's move on to R. Which recordings? Okay, now let's move on. Let's practice within R. Hope we're on the same page. Now, what R does? There is one inbuilt example that supports you when you're running an R Markdown. It's what we are going to first do, and then I'll give you an exercise. You get an R Markdown for the follow-up 1.R file. Okay, so now what we are going to do, you move on. You either go to File, then you move on to the first option, New File. New File, you move down to R Markdown. That is the first option. File, New File, move on to R Markdown. You click on it. This is the window I was telling you. So we are going to leave it in terms of a document presentation. So I can label my title. You put it any title that you want. Maybe they can't see. Let me ask in the chat. Can you make your screen more visible? Okay. Somebody's saying that we can see. Can you go to your R? Okay, go to R. From File, then move on to New File, then click R Markdown and see the screen that you're going to get. From the screen, they give you an option whether you want to change the title or not. Okay, let me cancel. I go back one more time. You go to File, New File, then R Markdown. Here, you're given an option to write, to rename. Instead of just having, it is untitled. You can put a name and save on how you want your script to look like. Let me call it my name. Let me call it Helen as the title of the R Markdown that I want. So by default, it will give you the HTML style, but you can also save it as PDF, or you can also convert it to Word. we're going to look at all these three options. If time doesn't allow, we'll have a small recap tomorrow. Okay, and then I say, okay. All right, hope you're doing the same. Now, the moment you say okay, in your R, you see what is happening. It shows you that the title, what you've labeled it, the author, most of the time it will put your name, the date, and then the output that you want it to be like an HTML document. Now, the other part that you have to be more, that is very important, is that within the R Markdown, we create chunks, okay? And this is the most important bit. How do you create a chunk? It's most important, because by the end of the day, you want to clearly put your work in a format that you can understand. This R Markdown that we have, it is by default. This is the default one they have put. They're telling you that this is how does a chunk look like? Within R, let me show you one here. When you check on your computers, go and click on where there is how do you refer to this? When you check on your on what? Yes, on the keyboard. Yes, on your keyboard, where there is a smile. On your keyboard, I don't know how your keyboard looks like, but you can, when you click, you see such symbols. You click them twice, no, 3 times. So I don't know how they call them. These ones like this. What's the name? No, they are not. These ones. This one here. What is it called? This is what I want. Yeah? They are quotes. Okay. Okay. Now you go to your where on your computer, and then you click the single quotes. Let me hope you're seeing what I'm doing. You click the single quotes 1, 2, 3, and then you open the bracket. You click inside there. We're going to write R, okay? And then the moment I enter, I click R, and then because inside I'm going to put, then I want to close that 1, 2, 3. The moment I close, it implies that whatever that I've done here, it is what I'm calling a chunk, where I'm going to put all my commands, everything that I need. I open it with these quotes. You have to click 3 of them, 1, 2, 3, then curly brackets R, then you put space, because inside here, I'm going to type in the various commands that I need, or whatever that I'm going to get from the R script, and then put it into the R Markdown. Let me check in the chat and ask, have you got how to create a chunk? Before we proceed. Okay. Yes, great. Okay, now let's proceed. It is something very easy. Just put the open quotes, count 3 of them, then open curly brackets, put R, put space, and then you close that chunk. So all the chunks that you're going to have, you can even go ahead and label them, the chunk 1, chunk 2, chunk 3, such that by the end of the day, R will tell you that, oh no, the problem is in, maybe there is an error in chunk 3, or there is an error in chunk 10. For example, in this particular case, now it is telling that if you're seeing where I'm moving my cache, it's chunk 1. Now I'm going to delete this because I don't need it. I was just showing you an example. Now within this R Markdown, the sample or the term, we're given a template. We can use this template and do a lot of things. We are given, this is chunk 1, okay, for it. They're telling you it's just like a setup, okay? Now, within the Kint, this Kint here, options, it is telling you that you set the chunk to equals to be equal to true. I'm going to show you how we are going to Kint, because it is right here. When you Kint, it will give you various ways on how you can do it. You can produce, Kinting is like creating to HTML, creating to PDF, or creating to Word, okay? So you're commanding, you should always have this embedded there to tell it such that R gives you an option to command it to any type that you're interested in. Within the R Markdown, you can create notes, okay? After a certain chunk, for example, in case, depending on how the size that you want to have, this is a title. You can write notes within R Markdown, or you can even write a publication in R Markdown, as we are going to see. So R Markdown in this particular case, these are just notes, okay? The chunks are being put where you've got the R commands that you want them to be executed. So they're giving you a brief introduction on what R Markdown is all about. So you can also do the same as you're writing out different notes within R. So if you want to write, for example, a manuscript, you can write within the R Markdown and then do the editing here and there. But as you're writing, we are seeing that there is a chunk here, and but this one, remember, I told you it's an inbuilt one. So they are considering cars. Within R, there are certain data sets that can support you in case you want to practice. So they are using the car data set. It's already embedded there. I'm just using this as an example. Then afterwards, I show you how can we take it now to our personal R files. Okay, this is a chunk which is being created, but most of the time what we are going to do, we are going to just have the quotes R, then we put space and then close. This one, it is just the data set that is embedded in R that they are using, so don't get confused about that. Like I said, like R Markdown, it's like a notebook. You can write notes, you can such that you're able not to go back again to run the different codes. You can include plots. In this particular case, yes, they opened a chunk. A chunk is only opened when you want to, and you're writing a code that you want to run. Only that's when we use it. And so in this one here, they are putting a plot, which plot is called pressure from the pressure data set. Also, this one is embedded within R. But like I said, it is a template that is being given to guide us, but we are going to say, how do you transfer this knowledge to our own data sets? Okay, you close that chunk and then also keep writing more notes the way you're developing a notebook. Now, let's first use this one that is being embedded within R and see how can we transfer this knowledge to the one we are having within the R script. So like I said earlier, you need also to save your R Markdown. I can click here and then I say, I can write and say R Markdown. My first R. You can save it any name, it doesn't matter. I just saved it like that into my file of the follow-up. So now after saving, what is the next step? Remember, it's a notebook. You're writing out your files and you want to refer to them later. So what you do after putting that within this R Markdown, there are only two chunks. There are only two chunks. We've got this one and then that one. But you can even have 1,000 of them, depending on the data that you are running. So what I do, you come here where there is Kint. Remember, this is the name I've saved, that first R Markdown. You come and say, you get on the drop down. And then you Kint or you create to HTML, you click that one. The moment you click on it, you have to give R time and then you see the output it produces. What it does when you kit it as an HTML, this is what it brings. Okay. Remember the title, your R Markdown, some notes that you're having there. It shows you the summary. It shows you the command. It brings the command and then the output. That's why I'm saying that the moment you convert in your R Markdown, the moment you kint it to either an HTML or a PDF or a Word, it implies that you don't need to go back to your R script because you'll have everything on you. And all you need to do is is either to transfer the result to your manuscript or to do that you write out the different tables that you want. So within the CAD data set, you ask for summary. It prints the command and also prints the output. Yet within the RStudio, we are seeing the results within the R console, but this time around, everything is put together. When you scroll down, it is also showing you, remember within another chunk, we wanted you to plot something. It is also bringing for you the plot that you want. Okay, now I'm going to close this and then I give you a simple exercise. Go into the, yes, somebody is saying that we'll have a recap tomorrow, no problem. Now I'm giving an exercise. Go into your R Markdown and then also kint for me an HTML in already the embedded template. Let's start from there. Within the template that is embedded there, okay, save it. You can save it with your name and then see if you're able to come up with an HTML output. You come here and then you kint to HTML. If you finish the HTML, kint to PDF or kint it to Word. Anyone who has tried? Error. Okay, another one. Yes. Kint to HTML and see the output. Kint to PDF and see if you're getting the output. All the output will be, you'll see your output in the same folder where everything will be saved in the same folder which you're working from. Yes, Word, HTML, yes, it is okay. I want to see more, yes. Kint, I want the HTML. I want to see, are you getting the PDF? Are you getting the Word? Okay. Can I proceed? So now, that's what I was saying, that with an R Markdown, you don't need any code. What we are going to do is to transfer our codes within the R script, and then we put them in R Markdown such that we are able to have our work stored very well. And we are able to refer to it. So it implies that this time around, even if you keep your work for 2 or whatever days and you've not really extracted the results, you can always refer to your R Markdown, either in an HTML or a PDF or a Word, and be able to present your work very well. Okay. Break the lecture into proportions. That we do not. Okay. Okay. People are complaining that they are tired. I'm going to stop here for today. Sorry. Yes, today's recording is going to be shared when it is ready. Just anytime, we'll be posting it on your email, and also you go through it very well. Somebody is talking about the recap of tomorrow, please. Yes, But now my homework, I'm asking you that from the little knowledge that you've understood, now try to convert the follow-up 1 R script into an R Markdown. Then we'll start from there tomorrow. It's the output that I want you to give down. I want you to go and create different chunks for the follow-up 1, R script. And then we'll stop there. Then we'll make a follow-up to a recap tomorrow. Thank you so much. Yes, we're also going to send the training materials for tomorrow. So you'll see everything on your email, and also going to create a Google link where you can, a Google Drive where you can pick all those materials. All right, thank you. Have a great afternoon, a great morning, a great, depending on your location. Catch you tomorrow. For those of you who still more help, we are going to be on the support link at 2. So we have 80 minutes. You've sent it? Okay. Professor Susan has sent a support link. So at 2, in case you feel something is not clear yet, we kindly encourage you to